Hey, fifth graders, we're going to tackle a brand new math lesson today. We are going to learn to multiply decimals. You'll be happy to know that multiplying decimals when we do it old school way, or in other words, the way that your parents learned how to do it, you'll be happy to know it's really not any different than multiplying whole numbers, which you already know how to do. You know how to multiply numbers like 34 times 12. Now, obviously, when you multiply decimals, our answers will be different, but the math facts will be the same. However, you know it's never that simple. We're always going to start by understanding the math first and doing it all these crazy new ways, which will help you better understand what we're doing. And then we will work with you on kind of what I like to call the old school method this week. So to get you started, we are on page 66 in your instruction book. So if you're not there yet, you can go ahead and pause the video and get yourself there. One of the highlights to doing the lessons on video is that you can pause them, you can rewind them, you can re-listen to anything that confused you at any time. You can even take the video and ask your parent if they can further understand or explain it to you if something that I'm saying is confusing. Don't forget, if you have questions, mark them. Make a note of it in your page. And then when you come back to school tomorrow, we can answer some of these questions for you. So today, we're going to tackle multiplying decimals. And we're going to start by taking a look at this problem right here. Okay? So we've got Margot, and Margot has 6 square tiles. Well, square is a good thing to note right away. What do we know about square? Is that all the sides are going to be the same length. So that's going to make things a little easier for us to get started. So each side of each tile, so each side, that's this side, and this side, and this side, and this side. Each side of each tile is going to be 8/10 long, okay? So I'm going to go ahead and mark that. That helps me. 8/10, 8/10, 8/10, 8/10, 8/10. That helps me understand. And then I also know that even the sides are going to be 8/10 going up and down. Okay? Now, it says if Margot places all the tiles in a row with the sides touching, which it appears she did that here, how long is the row? So in other words, they want to know how long this row of tiles is all the way from one end down to the other. Well, I think if we use our basic common sense, boys and girls, we would be able to figure this out, right? We know that all they're doing is putting 8/10 plus 8/10 plus 8/10 plus 8/10 plus 8/10 plus 8/10 plus 8/10. So if I put that all together and add them up, I certainly could do that. 8 plus 8 plus 8 plus 6 times, okay? I just got done learning how to add decimals, so I can do that pretty easily. I also know that this is called repeat addition. And repeat addition is a very simple but yet long process of making our lives not so easy. Instead of adding 8/10 plus 8/10 plus 8/10 plus 8/10 plus 8/10 over and over and over again, this is where we learn that repeat addition is the same thing as multiplication. So in other words, instead of adding 8/10 over and over and over again, I can do 8/10 times 1, 2, 3, 4, 5, 6 tiles. And that will tell me how long it is from end to end. But let's use some common sense first and look at question A. In order to make sure that we understand what we're doing and we're doing it correctly, they said, why don't you go ahead and estimate? Why don't you estimate to make sure your answer is going to be correct? If you look at the length of this tile and it is 8/10, what would you round that tile to if you were going to round it to the nearest inch, meaning the nearest whole inch? Well, boys and girls, 8/10 looks like this as a fraction. If that were a pizza, that would mean the whole pizza is cut into 10 slices and you have 8 of them. That's almost the whole pizza, right? So I would say we could round this up to each one of these being 1 inch, right? So 1 plus 1 plus 1 plus 1 plus 1 plus 1, okay? So we could round each tile to 1 inch, and that would give us an estimate that all 6 tiles put together is going to be about 6 inches, right? Okay. Now, will the actual length be more than 6 inches or less than 6 inches? Think about that. Here is the actual length. And here's our estimated length, 1 inch. What did we have to do to go from 8/10 up to 1 inch? We had to round up. What we really did was added 2/10. So if we had to go up and we're rounding up, that means when we add all those ones up, 6 inches is going to be more than our actual estimate. So our actual length is going to be less than the 6. The 6 inches is going to be more than what it really would be. Okay? And that is because we rounded each tile up 2/10. Okay? So I hope you understand that by rounding each tile up 2/10, the estimate is larger than the actual answer. Okay? Now, the length of each side of each tile is how many tenths of an inch? So let's go back. Each side of each tile is how many tenths? It is 8. 8/10. And how many tiles are there in the row? There are 6 tiles in the row. Again, if I'm going too fast and you're not sure, you can always pause and rewind so that you can have it repeated. Now, letter F. How many tenths of an inch long is the whole row of tiles? So how many tenths of an inch is the whole row? So if we have 8/10 and we do that 6 times, just think about that. Think about what those look like in base 10 blocks, boys and girls. We have the big hundreds block that we call 1 hole. Then we have those rods. Each one of those rods is a tenth. If you have 8 of them and you do 8 of them 6 times, how many of those tenths rods will you have? You will have 48. You know how I know that so quickly? Well, gee whiz, guys. 6 times 8 is 48. Now, that doesn't mean 48 holes. That means I'm going to have 48 of those rods. Just to refresh your memory, boys and girls, in those base 10 blocks, we're talking one of those. Okay? This is 1/10. So, in other words, if you can picture that there are 8 of these rods that would fit inside one of these tiles. Okay? How many of those would we need to make 1 whole inch? How many of those tenths rods would we need to make 1 whole inch? We would need 10 of them. Okay? Now think about this, boys and girls. If you have 48 of those, that's a lot. 48 of those rods. Just think about this. 1, 2, 3, 4, 5, 6, 7, 8. That's how many would be in one of those tiles. But what happens when I go on to the next tile and I put in just 2 more? How many of those tenths rods do I have now? I have 10 tenths. And what does 10 tenths make? 10 tenths makes 1 hole. So I have 1 hole already. So how many would 48 tenths be? Let's think. Let me erase up here. I'm going to draw this for all you visual learners. Just think about this. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Well, look, I'm going to take out 2 of these and put them with this guy. And that's 1 hole. Now I have 6 left. 1, 2, 3, 4, 5, 6, 7, 8. Oh, 8, 9, 10. There's another hole. All right, 1, 2, 3, 4, 5, 6, 7, 8. All right, 8 plus 2 of these. Look at that. I'm up to 3 holes. Look, 1, 2, 3 that I've made. 1, 2, 3, 4, 5, 6, 7, 8. Plus these 2. Look at that. 4 holes. And then 1, 2, 3, 4, 5, 6, 7, 8. I don't have 2 more to make 10 tenths. That would make a hole. But so what I do have is I have 4 holes and 8 tenths. How do I write? Whoa, look at this. It matches. How do I write 4 holes and 8 tenths? 4 and 8 tenths. Interesting. Look at my original problem. My original problem was 8 tenths times 6. What I came up with was 48 tenths. But who in the world wants to walk around with, that's like having 48 dimes in your pocket. Who in the world wants that? Nobody. We want to switch those out. When you can make a group of 10, like we did right here, that gives you 1 whole, like 1 whole dollar instead of 10 dimes. So what we've got is we were able to make 4 holes and 8 tenths. Interesting how the math fact is the same, but the decimal happens to be in between. Now, is 4 and 8 tenths a reasonable answer for what we came up with when we had our estimate of 6? Yes. Our answer is reasonable. Because 4 and 8 tenths is almost 5 holes, which is 1 hole away from 6 holes, which is our estimate. Okay? It says, use your own words to explain how you could find the length of the row of tiles. So what we can do is multiply the length of one tile, which is 8 tenths, by the number of total tiles, which was 6 total tiles. 48 tenths is the same as 4 holes and 8 tenths. Now, don't stress out. I know you're still trying to figure out how I knew that that decimal point went in between the 4 and the 8. We're going to do lots of practice, and when you come back, we can pull out those base 10 blocks, because I think what you need to remember, boys and girls, is that each one of these had just 8 of those base 10 blocks in it, 8 of these. But when you add up 8 plus 8, that's 16. Well, remember, when you got to 10, you could make a hole, and then that leaves you with 6 more tenths. So each time you were able to get to another 10, so when you got to 10, you made a hole right here in this 4. When you got to 20, that was 2 holes. When you got to 30 base 10 blocks, that was 3 holes. When you got to 40 tenths, that was 4 holes. But you couldn't quite get to 50. We only had 8 tenths left. So that leaves us with 4 holes and 8 tenths, 4.8. Okay? All right, so we're going to move on to the next page. So go ahead and take a look. It says, on the previous page, you saw that 6 times 8 tenths equals 4 and 8 tenths. How is this related? Or it's just saying, how does this compare? What's similar? What's different? How does this compare to 6 times 8 is 48? Okay. Well, notice that the digits of 6 times 8 tenths are the same as the digits 6 times 8. Okay. The digits of their products are also the same. Why is this? So why are the digits of 6 times 8 tenths the same as 6 times 8? Well, it's because we're still making 6 groups of 8. We're just not making 6 groups of 8 holes. We're making 6 groups of 8 tenths. So we're still going to have the same number of 6 times 8. It's just going to be parts now instead of holes. Okay? In earlier lessons, you learned that dividing a number by 10 shifts the decimal point to the left. So the value of the number, okay, so let's freeze there. In earlier lessons, this is the powers of 10 lesson. In earlier lessons, you learned that if you divided a number by 10, the decimal point went to the left. Okay, Mr. Down low. Remember, on a number line, boys and girls, every time your number gets bigger, it's being multiplied times 10. So the decimal point, when we multiply, the number gets bigger, so the decimal point goes to the right. But when we divide, a number gets smaller, so the decimal point moves to the left. So that means that the number itself, what it's worth, is getting smaller by 10 every single time. Because remember, when we divide, we're cutting it up. Each place value is worth 10. When we go backwards, it's getting smaller by 10, and when we go forward, it's getting bigger by 10. Okay? Dividing a number by 10 has the same result as multiplying the number by 1/10. Oh boy. Mind blown, that's super confusing, right? So let's just look at the table and see if we can figure this out. So 6 times 8. 6 times 8 means the same thing as 6 times 8 times 1.0. Well, that's just one whole. Okay, so 48 times one whole is 48. Look, it just has the decimal point and the 0 in the end. Okay, what about this one? 6 times 8 tenths is the same as 6 times 8 times, 1/10. So that's 48 times 1/10. Well, remember, when we've got it that way, the decimal point is going to go in between. 48 times 1/10 goes in between, 4.8. Look at what happens here. Oh, the decimal point's going to move 2 places. Look, because we have 2 of those tenths. So the decimal point in 48, which was over here, because remember, in whole numbers, the decimal point's hiding at the end. So 6 times 8 is 48. But really, it's 48.0, because 48 and 48.0 are the same thing. In all whole numbers, the decimal point is hiding at the end. Well, guess what? When you're multiplying it times 1/10, this time the decimal point is going to move 1 place to right there because of 1/10. But look, in this one, now we have 2/10, so the decimal is going to go whoop, whoop, and it's going to land right there. So now it's 48 hundredths. Okay, here it was 4 8/10. So notice that the decimal point moves 1 place to the left each time you multiply by 1/10. So what in the world do you think is going to happen with 6 times 8 thousandths? All right, let's just ignore this one fact for a minute. We know, pretend those aren't there for a minute. We know what 6 times 8 is, right? 6 times 8 is 48. Write that down on your lines. You can use up all that space. Where is the decimal point in 48 wholes? It's hiding at the end, remember? Now, how many, look at how many spaces we have, how many zeros we have. 1, 2, 3. So it's kind of, well, 3 places. So it's like having 1/10 times 1/10 times 1/10, because each one's a place. So in the thousandths, and Mrs. Miniger and I are going to show you easy ways to think about this. This is a complicated way to think about it. But look, the decimal is 1, 2, 3 places. So we're going to go 1, 2, 3 places and put in our 0 in that place value holder. So our answer to this one is now 48 thousandths. So look, each time this number gets smaller, this one will too, by that many places. Okay? I know this is tricky. Don't stress. We are going to go over this with you. Okay? That's kind of where we're going to stop on this page for now. So I'm going to end this video, and we're going to hop on over to your practice book. So you can go ahead and open up your practice book to lesson 8, and I'll give you the page number in the next link.